Now let's look at running the PCS principal component analysis for the entire data set. Okay, so um, what we're going to do is we're going to look at the predictors, and we're not going to use the first three because they are non-numerical. And of course, as I discussed earlier, they may be important variables, in which case you have to convert them into dummy variables and then include them in this analysis. Okay, so all right, let's call it PCS2. All right, so principal component PR comp BH. I'm sorry, not BH serial. So we're going to do NA omit serial dot df. Okay, and we're going to omit the first three, 1 to 3. Okay, and then let's do a summary of PCS2. All right, so now out of the 16 variables, we have removed 3, so we used 13 variables. And of the 13 variables, from the 13 variables, we have 13 principal components. Okay, and here we have the standard deviation in the first row, and then we have the proportion of variance accounted for by each principal component. So here, first component accounts for about 54%. And then the second component is about 39%. The combined PC1 and PC2 together, that's your cumulative proportion, accounts for 92%. And you keep going like that, and you see with 4 principal components, 99% of the variance is already accounted for. So from 13 predictors, we have reduced to just 4 predictors, still capturing 99%. Okay. Now, if you want a little bit more, you want 99.99%, then you get that with 7. So a little bit more than half the number of variables captures 99% of the variance. So that's a good deal of dimension reduction that's possible with principal components. And once again, here, once you have done the principal components, you need to get the, so say here, PCS2 X is what has the principal components, right? So, well, let's, that's, okay, let's, okay, so that's going to list the whole thing. Okay, so okay, so that's just the first one right at the top. Um, let's make that into a data frame. All right. So now we have PC1 through PC13. Okay. Now we may want only the first 4. So we say 1 to 4. Then you have just 1 to 4. Okay, you want up to 7. You're satisfied with 99%. Then you strip off the first 4. Then use that. Or if you want to go up to 7, then you come back here and then say, I want 7. And then you capture that as PCS, principal components, DF. Okay. So now we have the principal components here, 7 of them, and you can use them as your predictor in the further analysis. Now, there is one other important consideration. So, and that is, okay, let's go back to Excel, and it's probably easier to describe here. See, the value of z sub 1 and z sub 2 are going to depend upon the magnitude of the variables. Okay, so if you have really large values for a variable, then that will have a really large x sub 1 minus x sub 1 bar, okay, that deviation, and therefore it will have a larger values for z sub 1, and it will have undue influence on the variances that come out for the z sub 1 and z sub 2. Larger values will give you larger variance. So, in order to level the playing field, especially when you have, if the dimensions are all about the same, then it's okay. But if the dimensions vary among the predictors, then it's a good idea to scale them, okay, using standardization. So that's what that scaling is we saw earlier. So if you put scale dot equal to true, then the principal components will be computed after scaling the data. So let's call this PCS3, okay, principal component of okay, we can omit NAK serial dot df, and we don't want 1 to 3, okay, and then okay, so that's the NA omit, and then you say scale dot equal to true, and now you're going to have so let's do a summary of PCS3, and you'll see that it's different. So now the proportion of variance is much less for the different components, and for 99% you have to really go up to 10 principal components, okay? And for 99% you really have to go to 11 or 12. So one may try both ways, with scaling and without scaling, and then see which one gives you better results with the valid data set, and use that. So normalization is for leveling the playing field when the magnitude of the dimension of the variables, the magnitude of the variables differ significantly.